We can do arithmetic with polynomials in just the same way that we can do arithmetic with numbers. In a lot of ways, polynomials are analogous to the integers. All of the things we can do with integers, we can do with polynomials. And of course, the simplest arithmetic that we can do is addition. When we add polynomials, it just amounts to applying the associative and commutative property and combining like terms. So if we wish to add polynomials 2x squared minus 5x plus 6 and 3x squared minus 11x minus 5, we can apply the associative and commutative properties of addition and also the distributive property to combine like terms. And the result will be a single polynomial with only one term for each combination of variables, which is our goal. So how would we go about adding this if we really want to justify each step? So let's start by copying the given polynomial. We'd like to get rid of those parentheses so that we can combine our two trinomials here. And technically speaking, these include subtraction, which is not associative. So before we can get rid of the parentheses, technically, we need to remember that subtraction is just adding the opposite. So what we've done here is each instance of subtraction in the original has been rewritten as addition of a negative number. So that it's now clear that the only operation connecting these 6 terms is addition. Since that addition is associative, we can rewrite it without the parentheses. And now we have an expression with just a whole bunch of addition in it, no parentheses, and the fact that addition is also commutative allows us to change the order in which the terms appear. And the way in which we'd like to change the order is to put like terms together. So we have two terms with x squared in them, and we'll write those first. And then we have two terms with just x in them, and we'll write those next. And finally, we have two terms that are constants, and we'll write those last. And that has been just the commutative property. And now we want to combine the like terms. And the reason that we can combine like terms is the distributive property. So notice that these two terms each have an x squared. We can apply the distributive property to say that that's the same as 2 plus 3 times x squared. If I have 2 times x squared plus 3 times x squared, that's the same as 2 plus 3 times x squared. Next, we have two terms with just an x in them. And again, we use the distributive property to say that negative 5 times x plus negative 11 times x is the same as negative 5 plus negative 11 times x. And finally, we have two constant terms, which we'll just group together. So 6 plus negative 5 can be grouped together. And so in this step, we were applying the distributive property and a little bit the associative property to combine like terms. And now, of course, we just do that addition in parentheses. So 2 plus 3 is 5. We have 5x squared. And then negative 11 plus negative 5 is negative 16. We have negative 16x. And finally, positive 6 plus negative 5 is 1. And so here we were just adding numbers. And the last thing we want to do is just, here we have plus and negative, we want to go back to writing subtraction. So 5x squared minus 16x plus 1. And that was just the opposite of subtraction is adding the opposite. Adding the opposite is subtraction. And so we end up with a single polynomial. And we end up noticing that, for example, in all of that rearranging, everything that had subtraction, we treated as a negative number. And at no point did we change anything's sign, right? We aren't doing any add to both sides sorts of steps because we're just working within a single expression. Now, that was much more detail than we will typically write when we add polynomials. In this example, our goal was to see why this process works the way that it does. But in practice, when we add polynomials, we might write down one or two intermediate steps, or we might be able to just directly write down the sum. If we remember that negative signs go with the associated term, it is totally possible in an example like this to just directly write down the sum. So it can be beneficial to collect the like terms first. So here I have an x to the fourth term. I don't have anything else. So I'm going to have just a 3x to the fourth. Next, I'm going to collect the x to the third terms. So minus 5x to the third plus 3x to the third. Then I'm going to collect x squared terms. I've only got one of those. So minus 7x squared. I'm going to collect just x terms. I've got two of those. So 2x plus x. And finally, I'm going to collect constant terms plus 3 minus 11. And now that I have everything collected, I'm going to combine all my like terms. So I've got 3x to the fourth. Here I have negative 5 plus 3 is negative 2. So negative 2x to the third. Negative 7x squared has no like terms. 2x plus x, right? 2 plus 1 is 3. So I'll have plus 3x. And finally, 3 minus 11 is negative 8. So I'll have minus 8. And now I see that all my like terms are collected. That's my sum. This is typically how we'll write this. We might even skip this step. If you find that you sometimes lose track of some of your terms, writing out that step will be useful in not losing track of your terms. But if you find that you never lose track of your terms, you might be able to take a sum like this and just directly write down the result.